Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. Today I'll be discussing a concept regarding elongation of a bar due to its self weight. So as we have already discussed that when an external bar, when it is when it is applied on a body, there will be deformation or changes in size and shape of the body, but molecular forces which will be acting between the molecules of the body will resist the deformation of the body due to the external force, and this is termed as internal resistance developed by the body in order to resist the deformation in the body due to the external force. This resistance per unit area will be termed as stress. Same concept will be applied here when we will analyze stress and strain for a bar of uniform section due to its self weight. So here I have taken a bar which is AB shown in the figure. Let us assume that bar is fixed at one end and free at other end due to its self weight. So let us assume that the length of the bar is equal to L, cross section of the bar is A, E is the Young's modulus of the bar material, and specific weight of the bar, that is weight per unit volume of the bar, will be equal to W. So I just repeat it. I have considered a bar AB shown in the figure by assuming one end of the bar, that is at A it is fixed, so at B it is free, so it freely hanging under its self weight. So I have assumed that L is the length of the bar and A is the area of cross section, and Young's modulus of the material of the bar is equal to E. So W is the specific weight of the bar or weight per unit volume of the bar. Now I have considered a small strip which is of thickness equal to dx. So I have taken a small strip which is a shaded portion, you can just observe here. So its thickness is equal to dx, which is at the distance of x from the lower end, that is from face B, so which is as shown in the figure. So I just repeated. I have taken a section which is a shaded part which is having the thickness of dx and which is at the distance of x from the lower end, that is face B. So now I will consider the weight of the bar of length x in order to understand the load acting over the smaller strip of thickness dx towards the downward direction. So weight of the bar for the length x is given by P. P is equal to specific weight into volume of the bar up to the length x. So I just repeated. I will consider the weight of the bar for the length x in order to understand the load acting over the smaller strip of thickness equal to dx towards the downward direction. So I need to consider only the weight of the bar for length equal to x is given by, so P is equal to specific weight of the bar into the volume of the bar up to the length equal to x. So therefore specific weight, as I said, that it is taken to be as W. So volume up to length x is equal to area into length. So area is A, length is x, so W into A into x. So this is the weight of the bar for length of x. So as the weight of the bar for length x is acting on the smaller strip of thickness equal to dx towards the downward direction, so there will be some stress and some changes in the length of the bar due to the self weight. So therefore So therefore stress on the element is equal to, stress on the element is taken as weight acting on the element to the cross sectional area. So weight of the element per cross sectional area. So therefore weight acting on the element is nothing but the weight of the bar until the length x, so which is that we have determined here. So w into a into x, so divided by area of cross section is a, so a and a get cancels, so therefore the overall stress will be equal to w into x. So this is the stress which is induced, so for the length of x of the bar. So and from here we can easily conclude that stress induced in the length of the bar due to self weight of the bar will be directly proportional to x. So therefore stress is directly proportional to the length x here. So next thing is now we are going to determine the strain and elongation of the smaller elementary strip here. So that is the shaded portion. So strain in the element, as we know that strain is equal to stress to the Young's modulus, that is stress by Young's modulus will give the strain. So stress in the previous slide we have determined it as W into X. So E is the Young's modulus. So therefore strain is equal to Wx divided by E. So next is the elongation in the smaller strip or elementary strip. So elongation is nothing but strain into length of the smaller strip. So strain we have got it here, it as Wx divided by E. So length of the elementary strip is dx, that is nothing but only for that element we are going to consider. So that is the thickness dx. So w times of x into dx divided by E will give you the elongation of the element. So next is this is for the elongation for the elementary cross section or the elementary step. So in order to find out the elongation of the bar due to the self weight, that is the total elongation of the bar due to the self weight is obtained by integrating the equation of the elongation of the elementary section with reference to limits 0 to L. So therefore delta L will be equal to integration to the limits 0 to L Wx dx divided by E. So here W by E is a constant, so that we will take outside the integration. So therefore integration limits 0 to L x dx. So it is x square by 2. So WL square divided by 2E is the value. So therefore it can also be written as W into L divided by 2E, wherein small w into L is equal to capital W. Small w is the uniformly distributed load, wherein its unit is kilonewton per meter or kilonewton per mm, like that, or Newton per meter. So length into multiplied with that of the length if we do, so we'll get the value of weight load in terms of kilonewton, that will be the considered as a point load. So therefore W into L will be taken as W into L is taken as capital W, that is nothing but the point load. So therefore it can also be represented as WL by 2E. So therefore the total elongation of the bar for the the total elongation of the bar due to the self weight will be equal to WL by 2E. Thank you for watching. Please like, share and subscribe the video. Thank you.